Hello and welcome everyone. Here we are to see how to solve system of linear equations using Cramer's rule. In our previous video, we have seen how to solve system of linear equation by row reduction method, but this time we will see Cramer's rule. He is a mathematician. He states methods or rules to solve system of linear equation in matrix. So what does this rule says? If we have a system of linear equation like a1x plus b1y plus c1z is equal to d1, let's say, and the second equation, let's say a2x plus b2y plus c2z is equal to d2, and the third one, let's say a3x plus b3y plus c3z, it is equal to d3. Therefore, first we have to find determinant of the coefficient matrix, let's say D. The determinant of the coefficient matrix, we are going to take the coefficient number here. A1, B1, C1 as a first row, that is A1, B1, C1, this is D. And again, the coefficient, the second row will be the second coefficient, that is A2, B2, C2. And the third one is A3, B3, T3. These are the coefficients of the determinant of the coefficient matrix. And then we need to find dx again. Dx means the coefficient, the first column, okay? This is corresponding to x's, and the second column corresponds to y, and the third one, it is corresponding to z. So the first column will be replaced by the constant here. We'll bring it. So it's going to be d1, d2, d3, and the second one as it is, b1, b2, b3. The third one again as it is, it will be C1, C2, C3. This is dx according to Cramer's rule. Again, we need to find dy. Dy again, it's going to be the second column will be replaced by the constant. But the first column as it is, A1, A2, A3 will remain as it is. And D1, D2, D3, you see the second column is replaced. And then C1, C2, C3. The third one, nothing is changed here. And now we'll find dz. Again, the same manner to find the dz, we need to replace the third column. That is, dz will be the first column as it is, a1, a2, a3 will remain, and b1, b2, b3 as it is, and the last one, d1, d2, d3. Okay. We do have everything here. Therefore, to find the x value or the solution for x will be, the answer is dx over d. And again, to find the y value, we can use dy over dz, d. And finally, the z value will be dz over d. So we need to calculate around 4 determinants. You know, determinant of 3 by 3 matrix, it takes somehow time taking. So finding all 4 determinants and then dividing, it's really, in this case, it's somehow a long process, but we don't have choice. This is the way how to solve using Cramer's rule. But remember, if the determinant of the coefficient matrix is 0, okay, we can have 2 possible cases. If the determinant of the coefficient matrix, okay, let's correct this D. Okay, the determinant of the coefficient matrix, if D becomes 0, as you see, since the D is a denominator, there will be 2 cases we can consider. The first case, at the same time, if dx 0 and if dy also 0 and dz also 0, it will have many solutions. Many. But if d is 0 and dx, if it's different from 0 and dy also different from 0 and dz also different from 0, it has no solution, we can say. And the second, these are the 2 cases, it depends on d. But if d from the beginning, if it's different from 0, if the determinant of the coefficient matrix is not 0, the given system of linear equation has unique solution, we can say unique. Unique solution means x will have 1 value, y also 1 value, and z also 1 value. So there are 3 possible cases we can have for system of linear equation. Those 3 cases are a given system of linear equation may have a unique solution or many solution or no solution. Anyways, let us see one example. This example will be the one that we did previously by row reduction method, and let us even cross-check how the answers are the same. Okay, for this matrix, to solve by Cramer's rule, first of all, let us find the coefficient matrix, D. So the D will be here. It's going to be 2, -4, 6. And the second row will be 6, 2, -2. And the third row will be 2, 3, -5. This is the coefficient matrix. I took all the coefficient here. So this determinant, you know how to find. Just to show you how it comes. First, we'll take the first entry, 2 here. And then at this point, we'll cancel everything, the first row and the first column. Then the remaining, I will take the determinant of it. So it's going to be the determinant of the remaining will be 2, -2 and 2, 3. 2, -2 and 3, -5. Okay. Okay. So it's going to be 3, -5. Then minus the second column, the second entry in the second column, we'll take -4. You know, it is plus, minus, and plus previously we have seen. So it's going to be negative of -4 will be +4. Then second column and first row will be eliminated. So 6, -2 left here. And the last one, 2, -5 left. Then at last we'll make 6, then the determinant of the remaining. The last column and the first row will be cancelled. What left here? 6, 2, and 2, 3. We need to take care when we are doing this one. Therefore, 2 in bracket, main diagonal first, 10 minus -6 means +6. Then plus 4 in bracket, 6 times -5 will be -30 minus, or that's going to be +4. You need to take care. Plus 6 in bracket, 18 minus 4. Let us complete it. This is going to be 16 times 2 will be 32. Here, -26. -26 times 4, it will be 4, and 4 times 2, 8. 8 and 2 is 104. Then plus, here 14. 14 times 6 will be, again, 4. And 6 times 1 and 6. 6 and 2 will be 84. Therefore, when we are trying to calculate this number, it will come 12. This is D. So D, as you see, number 12, it is different from 0. So the given system of linear equation necessarily will have a unique solution. So we have to continue. But if this becomes 0, we can stop here. But if we are asked like the general outcome, we may say it has many solutions or no solution. It depends on the next determinant, dx and dy and dz. But this time, the determinant of the coefficient matrix is different from 0, which comes 12. Therefore, we have to continue to find the dx, the dy, and the dz. But when we are trying to find the dx, we have to replace the first column. As you see here, the first column, all these numbers will be replaced by the constant here. The constant here, it is -801. Okay, let us do that one. Okay, now in this page, let us bring the determinant numbers of. So it's going to be the first. Okay, so the determinants of the dx will be, let us bring it. It's going to be dx is equal to, the first column will be replaced by -8, 0, and 1. And the second column, it is -4 as it is, 2, 3. And the third column, it's going to be 6, -2, and -5. This is the second column. Then when you try to find the determinant of this matrix, we will see the result of this determinant. We have to solve it the same manner like we did before. So the result, it's going to be 28. You can solve and check. In the previous page, I think here there is one mistake. Let us correct it. that is when we are trying to multiply here 2 times -5, this must be -10. So -10 plus 6 is -4. -4 times 2, it's going to be -8 here. So this is -8. So finally, the result will be -28, the d value. Okay, let us correct this one. This is -28. -28. Okay, the same manner here. Still, the determinant is different from 0. So that is -28. Okay. Now let's get back to the next page. So when you come to here, we found now the value of dx, and let us do the value of dy. Therefore, dy will be, okay, the dy will be 262, the first row, the first column, no change, but the second column will be replaced by the constant -801, and the last one as it is again 6, -2, and -5. So again, we need to calculate the determinant of this matrix, and let us see the outcome. So the determinant of dy, as you see, it's going to be positive 168. How comes? The second column, it is replaced by the constant, that is -801. And when you are trying to find the dz, again, the last column will be replaced by the constant. So as you see here, to find the dx, the first column is the constant, and to find the dy, the second column will be the constant, and to find the dz, the last column will be the constant. Therefore, these are the outcomes. Then, once we have the constant, so we can find now the x, the y, and the z value. The x value, we said already, dx over d, which is 28 over -28. We have got it. So the x value is going to be -1. This is x. We can check the d value here. We did it already. The d value is -28. Yes. So that's correct. And to find the y value, again, the same process will apply. Okay, it's going to be y value is equal to dy over d, which is the dy is 168. We got it over -28. So it's going to be -6. That is a y value. And finally, the z value, which is dz over d, which is -84 over -28, which will be +3. So these are the three answers. So finally, the answer will be the same like we have got in previous one. So the solution set, we can write it first brace, then in bracket, -1, -6, and 3. This will be the 3 solutions. So that the answer will be the same like the previous one. But here the dy, it must be negative. So when you divide by negative, the result will be +6. So this one, it's +6. So in our previous solution, even in row reduction method, the answer, it was -1, 6, and 3. So we did it the same manner. So in general, remember the rule here, what I told you. First of all, take out the quotient matrix and represent by d. The determinant of the quotient matrix will be the d. And if it is 0, we will stop there solving. To check whether it is many solution or no solution, we have to check dx and dy and z. If one of it is different from 0, it's going to be no solution. But if all of them, they become 0, it's going to be many solution. So these are the cases. Therefore, we need to find the dx, the dy, and the dz. Then the x value is dx over d, and the y value is dy over d, and the z value is dz over d. But what is the advantage of Cramer's rule than the row reduction? Row reduction method, okay, sometimes which row will be exchanged, which row will be multiplied by a constant and added in which row. It is somehow confusing for the student. But this one, it has at least formal process. It has formal process. Every one of you can apply and solve using Cramer's rule. So thank you for watching. Don't forget to subscribe. I will come back with other videos. Thank you.